Okay, so in the last video, we had we had a problem description laid out, and we are looking at this shuffle merge on two singly linked lists. And what I've done here is I've just depicted the same problem again, and I've got my two singly linked list. The first one represented by head one, and the second singly linked list represented by head 2, and what I would like to do now is perform a shuffle merge on these two singly linked lists by where I keep on alternating between every node of my singly linked list starting from head 1. Okay, now, because this is going to be an iterative solution, this is a non-recursive solution, so I'm going to build my solution using loop invariant. And because I'm going to use loop invariant on my solution, let's propose what is an appropriate or a strong loop invariant that I can actually form on this problem. So what I'm going to say here is let's just assume that I've got this let's just say I've got this brown vertical line here, and what I'm doing is I would like to present my loop invariant using pictures, and because if I do it via pictures, we're going to get a much more stronger intuition behind why is it that the code that I'm going to get in this video is going to be at least correct in the very first try that I attempt. Okay, so given this vertical brown line here, what I'm going to propose here is that everything on the left of this brown line, meaning everything on the left, has already been merged. Okay, that's the assumption here that I'm making, that everything on before or on the left hand side of this brown line has been merged, and everything on the right is still remaining. Everything on the right is still remaining to be addressed. So what would this picture look like? What is it that I have accomplished at this point here? So again, if my loop invariant says that everything on the left of this brown vertical line has already been shuffle merged, my picture, at least on the solution base, would look like something like this. I have these two nodes here with the values 1 and 7, where they have already been merged here. Okay, so think of this just from a picture perspective. Think of this is what the solution currently looks like, because everything before this brown line has been merged, and this is what the solution is before the brown line. Now everything after the brown line is still something that needs to be merged. It's still something that needs to be addressed. And the way we're going to do this is I'm going to assume that I've got these references at my disposal. So I've got this reference I that is currently pointing at the node with the element 2. I've got another reference j pointing at the node with the element 13, and then I'm going to have two further new references. Let's just call this as I next. Okay, this is because this happens to be one after I, so I'm just going to give it a name I next here, that happens to point at the node with the element 3, and then I have something called j next that points at this node with the element 1. Okay, now again, what my loop invariant says is that if you look at this I and j is always one after this vertical brown line, right? They always point at this node that needs to be merged here. Okay, so think of I and j as pointing at these nodes that need to be merged here. Okay, so given this picture here and given these local variables here, what would the next immediate step be at this point? Well, the next immediate step at this point would be I would have to take this reference, this reference that I'm currently pointing at, take this reference and make it point at the node with the element 13, and then take the next reference of the node with the element 13 and make it point at the node with the element 3. I mean, that would the very next immediate step be. Okay, so how would I do that? How would I write those two lines of instructions that would actually perform these step of sequences for me? So if I were to write my solution in this silver color, I would say at this point let's have I dot next. Let's have I dot next equals to, because this is entire thing is I, and what I'm saying is that I dot next, which is this piece here, I dot next should equal to wherever j is pointing at, and I want to say j dot next, which is this piece over here. J dot next should be pointing at wherever I dot next is pointing at. So j dot next should equal to wherever I next is pointing at. Okay, so with these two sets of instructions, what has happened so far is that if you think about this vertical brown line, where would this vertical brown line have moved now? So I've got everything up to, so just I have this continuity on my picture here. What I have is 7 in this case, because everything before was already done for me. That was the assumption I started with, and because that was the assumption I started with, 7 at that point. So the next on the node with the element 7 should be pointing now at this at let's just make sure my color is consistent. So this was in green, a shade of green here. So let's just get the same color. So this is going to be 2, and now I'm going to have at this end with the element 13. Okay, and so my brown vertical line, if I'm just being consistent with this brown vertical line, it has moved at this point just after the node 13, because if you look at this, I've just performed these 2 lines of instructions, and that has technically, in theory, moved this brown line towards a point where everything before this has been merged, right? I just performed these 2 instructions that got merged, 2 and 13, and I'd already assumed everything before that had already been merged here. So I'm just moving this brown vertical line towards the right. Okay, but my loop invariant was that this I and this j. Okay, if this brown line has moved over here, this brown line, again from picture point of view, just to be consistent on this space here, has actually moved to that end now. Okay, but what did my loop invariant tell me? My loop invariant told me that this I should always point at one after the brown vertical line, and j should always point at one after the brown vertical line. Okay, so before the next iteration of my loop begins, I must make sure that the loop invariant holds, that the loop invariant isn't getting violated. So what I'm going to do now is, with these 2 instructions here, let's first make sure that I, which is currently still pointing at this node with the element 2, it should now point at whatever is the node after this brown vertical line, meaning it should be pointing at this node with the element 3. So what I'm going to have now is I'm going to say I equals to I next, and I'm going to say j equals to j next. Okay, so I is now pointing over here, and j is pointing at this node here. But again, as per my loop invariant, I next should be pointing at 1 after I, and j next should be pointing at 1 after j. So let's just add 2 more series of instructions there, just so that my loop invariant holds. So I'm going to say I next equals to I next dot next, and of course this is assuming that that I can always refer to this to these instance. So this is my instance member, referred to by instance member next, and this over here could be considered as my element. This is my element, right? So I'm saying I next dot next, and then finally I'm going to say j next. I'm going to say j next equals to j next dot dot next. So what has happened here is j next, which was originally pointing at this node with the element 1, is now pointing at none, and I next is now pointing in this picture at none. But if you look at this picture, if you look at my loop invariant here, my loop invariant is completely consistent, because after this brown vertical line, if I look at I and if I look at I next, I'm completely preserving the new values of I and I next as 1 and 2 after the brown line. This I over here is just 1 after the brown line, and if you look at I next over here is pointing at 2 after. It has a displacement of 2 here. And same thing with j and j next, and I'm maintaining the same loop invariant that I originally started off, where I had this I and I next in blue and j next in blue that were just 1 after the previous brown line. So I'm going to continue on this in my next video. So we're going to pause over here, but we're going to continue getting this code completed in my next video.